I took one of the most familiar low-cost of VR programmers, the USBasp, and pushed it far beyond the performance people normally expect from it. The standard firmware gave me about 2.54 kilobytes per second write speed and about 3.75 kilobytes per second read speed. My current FDxUISP firmware has reached 11.56 kilobytes per second write speed and 12.65 kilobytes per second read speed. That means the write speed is more than 4 times faster than the original default firmware. The read speed is more than 3 times faster. And I achieved this while keeping compatibility with the normal USBasp protocol and standard of AVRdude. This was not a simple firmware edit. I went through version after version. I tested different target processors, different clock speeds, different page sizes, different flash sizes, and different transfer conditions. I tested small files, 16 kilobyte files, and files close to the full 128 kilobyte capacity of an ATmega128. I did not accept theoretical improvements as proof. Every important change had to survive real hardware testing. I measured the writing time, I measured the verification time, I calculated the actual transfer rate, I compared every new version against the previous one. Some ideas looked excellent on paper but performed worse on the device. I tested larger memory buffers, I tested different data flow designs, I tested direct transfer methods, I tested more aggressive timing, I tested low-level variable changes. Some versions improved reading but reduced writing, some improved one benchmark but failed to improve the full programming process. When an experiment made the firmware slower, I removed it. When one version had the best writing performance and another had the best reading performance, I studied both and combined the strongest parts. That process eventually produced version 1.6. Version 1.6 is currently my best confirmed release. It achieved 11.56 kilobytes per second writing and 12.65 kilobytes per second reading on a large real-world test. It can automatically select a suitable programming speed for the connected target. It can work with fast targets, slower targets, and very slow recovery conditions. It supports flash memory, EEPROM, signature reading, fuse reading, and normal USBasp operations. It still works through a AVRdude. It does not require a special private programming application just to demonstrate a high number. The speed is visible directly in the AVRdude output. I also created automated test procedures to check the firmware across different programming speeds. These tests cover the original USBasp baseline, fast 3 MHz operation, slow software operation, flash programming, EEPROM programming, signature reading, and verification. This project required more than writing code. I had to understand the hardware, question old assumptions, recognize incorrect explanations, isolate regressions, preserve working versions, and keep reliable records of every meaningful result. I repeatedly returned to earlier firmware when a newer experiment failed. I did not keep a change simply because it was more complicated or looked more advanced. The goal was not to create the largest firmware. The goal was to create the fastest reliable firmware. FDxUISP is the result of that effort. It takes an inexpensive 12 MHz ATmega88 based USB programmer and gives it performance that is dramatically higher than the original firmware. The final result is not a simulated estimate, and it is not an unsupported claim. It is measured on real hardware using real target chips, real flash programming, and real verification. That is what I achieved with FDxUISP.